So I like this section because now we get to, why the heck did we tell you about all that stuff? Why do you need to know that? Well, it turns out this quantum mechanical model helps to explain a lot of the things that we observe about atoms and elements and how they react with each other. The chemical properties of the different elements are largely determined by the number of valence electrons that they have. This explains the periodic law. Remember, the periodic law said that properties recur periodically, and the periodic table was set up so that the halogens are all on top of each other because they behave in many of the same ways. Now we can see why they do that. They all have 7 valence electrons, and so they're going to behave in a similar way. The noble gases are very inert. They all, except for helium, they all have 8 valence electrons. And that is why they are very inert. We talked at the beginning of the chapter about hydrogen and how it's very reactive. How many valence electrons does hydrogen have? This isn't a trick question. 1. It only has 1 electron. It's the valence electron. Hydrogen has 1 valence electron. That orbital is half full. How many valence electrons does helium have? 2. That one is full. The first level for hydrogen is not full. The first level for helium is full. And it turns out that when that level is full, that results in a lowering of the energy. And everything in nature tends towards lower energy. So helium is more stable than hydrogen. Hydrogen is not very stable. And so it reacts in a way to stabilize itself. So here are the noble gases, group 8A. They have 8 valence electrons except for helium. We predict, looking at their electron configurations, that they would be very stable, and we also observe this in practice, that they are very stable. So in Mrs. K's chemistry land, the noble gases are like the cool kids in high school, that in-group that so many other people just really wanted to get into but couldn't because you didn't look right or didn't have the right clothes or something, right? These guys are cool. They've got 8 valence electrons. They're set. They don't need anything from anybody. And that's why they don't react with other elements. The alkali metals have 1 valence electron. They are very unstable. Look at sodium on the periodic table. It has 11 electrons, right? 1 valence electron. If we remove the 1 valence electron, how many electrons does it have? It has 10. It has the same number of electrons as neon. Neon is very stable. So how I think of that is that sodium came to school wearing an ugly sweater that his mom made him wear because she said it was going to be cold, and it's not. Sometimes moms are wrong. You should still bring a sweater, but you don't have to wear it. So sodium gets to school, and the cool kids are looking at him like, what the heck? So he goes into the bathroom, he takes his sweater off, and then he comes back out, and now he fits in better. Did it change who he was? No, it just changed how he looked. So sodium doesn't change what element it is by losing an electron. It still has 11 protons. But the outside of the atom becomes like neon. 8 valence electrons, a total of 10 electrons. That's a stable configuration. So we learned earlier that sodium tends to form a +1 ion, right? It does that by losing 1 electron. Why does it do that? Because it wants to have 8 valence electrons. And by losing 1 electron, it can have 8 valence electrons. All of the group 1 metals do that. They lose 1 electron. Losing 1 electron is easier than losing 2 or 3 or 4 electrons, and so they react very easily to get those 8 valence electrons. So that explains why they're so reactive and why they tend to form +1 cations. The alkaline earth metals. Group 2A. How many valence electrons do they have? 2 valence electrons. So when you take those 2 valence electrons off, what's underneath? A full sublevel, right? And so you remove the 2 on the outside. Now you're down to the next level, and these guys are going to have 8 valence electrons. These guys are also quite reactive, and they tend to form +2 ions, because by losing those 2 electrons, they can get the same electron configuration as a noble gas. Does that make sense? They're trying to be like the noble gases. Halogens. How many valence electrons do the halogens have? 7. So how could a halogen get 8 valence electrons? Add 1. That would be the easiest, right? They could add 1 electron, or they could lose 7. Losing 7 is going to be a lot of work. Adding 1 is going to be easier. That's why the halogens form -1 anions. By gaining 1 electron, they get the same electron configuration as the noble gas right next to them. This is the girl that just needs to put on a headband to look like the cool kids, right? So we see these these elements that form predictable ions. We just kind of learned this by, counting and wrote off the periodic table. Now that we know about electron configurations, we understand better why they do this. These all have 1 valence electron. They tend to lose that and form +1 ions. These guys have 2 valence electrons. They lose those and form +2 ions. Over here, the halogens have 7 valence electrons. They're going to gain 1, forming -1 ions. When they gain 1, then they have 8 valence electrons. Oxygen, sulfur, selenium, tellurium, 6 valence electrons. To get 8, they need to gain 2 electrons. Nitrogen and phosphorus have 5 valence electrons. They need to gain 3. So that's where the group number -8 comes from, or the counting backwards from the noble gas. How many more electrons do we need to get over here? These guys need 1, these guys need 2, these guys need 3. What about those guys in group 4? What would they have to do? They would either have to gain 4 electrons or lose 4 electrons. It's kind of 50-50 either way, right? For the most part, they don't do either. They don't really make ions. It's too hard. There's there's just no hope of having 8 valence electrons that way. I'm just not even going to try. Those are the ones that they're just kind of okay with being nerds. And here, aluminum, gallium, indium. These guys have 3 valence electrons. And so they're going to lose those 3 valence electrons and form +3 ions. Any questions?